Today we're going to look at finding the area under a normal curve. So first off, notice we have a normal distribution at the top here, and it has mean mu and standard deviation sigma. So we have mu right in the middle, we have one standard deviation above the mean, one standard deviation below the mean, and so on. And for a normal distribution, we call our random variable x. We also saw the standard normal distribution, which has a mean of 0 and a standard deviation of 1. So we have the mean right in the middle, and we can easily label 1, 2, or 3 standard deviations above the mean, or 1, 2, or 3 standard deviations below the mean. And last time we saw how to find the areas under this standard normal distribution using the standard normal table. So if we had a z-value, by the way, for the standard normal distribution, our random variable we call z. So suppose we picked a positive z-value, somewhere between 1 and 2, right? And we want to find the area under the curve and to the left of that z-value. Well, we saw that the standard normal table is what gives us this area. What we would like to do is to be able to do a similar thing, but for any normal distribution, right? So suppose I pick an x value over here, and suppose I want to find the area to the left of that x value and under the curve. Well, we're going to see how to do that today. We could also maybe figure out how to find the area above that x value, right, or to the right of that x value. Or we could even find the area between two particular x values. So we're going to see how we're going to do all of those today. And in order to do this, what we need to do is convert our x values into z values so that we can use this standard normal table. And the way we're going to do that is by looking at our formula for the z-score. Right? When we find the z-score of a particular x value, well, that's how we convert. That's what we call standardization. So remember, the formula for the z-score is we take our particular x value, we subtract the mean mu. Notice if x is bigger than the mean, if it's larger than the mean, then this value up here will be positive. And if x is smaller than the mean, then this value up here will be negative. And then what we have to do is divide this by sigma, our standard deviation. All right, let's look at some examples. So suppose we have a random variable that is normally distributed. That means it's going to have this bell shape. And the mean is 20, and the standard deviation is 5. We're going to find the following probabilities, and we're going to sketch the corresponding area under the normal curve. Okay, so for part A, here's our bell-shaped curve, and our mean is right in the middle. Our mean is 20, and we want to find the probability that a particular x value is less than 10.4, less than or equal to 10.4. So here's 10.4. Notice it's below the mean, and notice our inequality says x is less than or equal to 10.4. So that means we're interested in finding the area to the left. And well, in order to do that, we need to convert into a standard normal distribution. So I need to find the z-score of 10.4. So using our formula, we'll get 10.4 minus the mean 20 divided by the standard deviation, which is 5. And so what does this give us? 10.4 minus 20 is negative 9.6. Divided by 5 gives us a z-score of negative 1.92. Okay. So if I were to draw my standard normal curve here, so here now our mean is 0, and a z-score of negative 1.92, that's down here somewhere. And this is the area we need to find, which notice that's the same area as we have over here. Okay, and in order to find this area, well, this is where we're going to use our table. So the probability that z is less than or equal to negative 1.92, let's refer to our table. So here's our standard normal table. Notice we have negative z values, and the z value we're interested in is negative 1.92, so negative 1.9, that's over here. And then the hundreds place 0.02, that's over here. And where do these meet? My area is 0.0274. And there we go. This gives us the area, this area of the shaded region, which is the same as the probability that z is a value less than or equal to negative 1.92. Okay, let's do part B. So now we want to find the probability that x is greater than or equal to 26.5. So first let's draw this. So I got my mean of 20 in the middle. 26.5, that's above the mean, so that's maybe over here somewhere. Okay. And notice my inequality says greater than or equal to. So that means I'm interested in finding this area to the right of 26.5. Okay. Well, let's, first of all, let's go ahead and convert this because we know we need to convert it to the standard normal distribution. So the z-score of 26.5, that's going to be 26.5 minus the mean 20 divided by the standard deviation 5, which gives us 6.5 over 5, which is 1.3. So in terms of a standard normal curve, this is what our picture now looks like. Our mean of 0 in the middle. Here's our z-score of 1.3, and we want to find the area to the right. Now, if we were to use our table, the table actually gives us the area to the left. This is what our table would give us. So how do we find the area to the right? Well, if you remember from last time, there's actually two methods. So our first method is basically using the complement rule, which says, well, I know the total area under the entire curve is equal to 1. And well, if I were to look up in the table what this area is, right? Well, all I need to do is take 1. So our area is going to be 1 minus whatever this table gives us, and that's going to give us the area to the right. So remember, what the table gives us is the probability that z is less than or equal to 1.3. Okay, so that's this here. That's what the table gives us. But when we subtract from 1, that's going to give us the area that we want. Okay, so let's see. 1 minus what is the probability that z is less than or equal to 1.3? Now we have to look up in our table. So let's see. Here's our positive z values, and what we want is z is equal to 1.3. So 1.3, here it is. Notice my hundreds place is just 0. So 0.9032. 0.9032. And when we subtract that from 1, so what is 1 minus 0.9032? We get 0.0968. And that is the area that we want. Okay. So that was the first method. Remember, the second method says that by the symmetry of this standard normal curve, or any normal curve for that matter, this area here to the right of 1.3 is actually equivalent to the area to the left of negative 1.3. Right? These areas are the same. So all I need to do is look up in my table, what is the probability that z is less than or equal to negative 1.3? And so let's look up in our table. So now we want z is equal to negative 1.3. So that's this guy here. And we get 0.0968. So 0.0968. Oh, and notice that is the same exact answer that I got over here, as they should be the same. In fact, this is a good way to check your work. If you try both methods, you should get the same answer. Okay, let's try the last part of this problem. So we're going to consider the same problem with a mean of 20, standard deviation of 5. And here's our problem. We want to find the probability that x is between 18 and 20. So let's first draw this. So our mean 20 is in the middle. Here's x equals 18, which is below the mean. And here's x equals 28, which is above the mean. And we want to find this area, right? Notice we have that 18 is less than or equal to x, which is less than or equal to 28. So basically x is between these two x values. And while first thing we need to do is convert this into a standard normal distribution, right? So that we have 0 in the middle. Notice that the z-score for 18 should be negative. The z-score for 28 should be positive. Let's go ahead and find these. So z-score of 18 is going to be 18 minus 20 over 5, which gives us negative 2 over 5, which is negative 0.4. And if we find the z-score of 28, we'll get 28 minus 20 over 5, which is 8 divided by 5, which gives us a z-score of 1.6. Okay, so on my standard normal curve, here's a z-score of negative 0.4, and here's a z-score of 1.6, and we want to find the area in between these two z values. Okay, so let's look up in our table. Oh, and how are we going to find this area? Well, I could find the area to the left of 1.6, sorry, that would be this here. But then I want to get rid of this stuff here. So what I need to do is subtract the area to the left of negative 1.4. So as a formula, it would look like this. Probability that z is less than or equal to 1.6, that gives us this entire area to the left, minus the probability that z is less than or equal to negative 0.4, right? And what that does is it basically subtracts this area to the left of negative 0.4, and that's going to leave us with the area that we want in the middle. So we can look up these areas or probabilities in our table, which I actually did earlier. I saw that for the z-score, with a z-score of 1.6, that this area is equal to 0.9452. And when the z-score is negative 0.4, I saw that the area is 0.3446. So again, these guys I just got using the table. And now when I subtract these, so 0.9452 minus 0.3446, that's going to give us a difference of 0.6006. And there we go. That's the area in between these two z values, which is the same as the area in between these two x values. And there we go.